welcome to a new open class. Welcome everybody. So today we are going to have the class number 3, the last class of this series of classes that we have been doing related to how to use ChatGPT to improve your ROS and robot development, right? So yeah, first of all, as always, let me know if everything is fine, if sound is fine, if image is fine. I'm going to check here the comments to make sure that everything is good. So yeah, let me know. And then yeah, so let's don't lose any more time and let's get started. So I'm going to switch right now to my computer screen. Let's go there. Here we are. Let me come here to the class. Okay, so Andres, Sonia are saying that everything is fine. Excellent. Okay, yeah, then, so welcome everybody. And today we are going to be talking about how to use ChatGPT in order to understand third-party ROS code faster. Okay, I'm going to explain a little bit more about this in a moment. But before actually getting started, remember that the very first thing that you must do in order to be able to follow properly the class is to get today's rosject. So let's do this right now. Remember, in order to get the rosject for today's class, all you have to do is to click here in the button that appears right above the chat, which says fork, and open the class rosject. So I'm going to click here myself right now. Let's go there. And yeah, so after some seconds where the project is going to start loading, let me mute this here. Okay is asking, is this a free event? Yes, sure. This is 100% free. Okay, yes. It's a free open class. Anybody who wants can join. All right, then the very first thing that you have to do, as I was saying, is to get today's class. All right, so yeah, then once you click on the button, you are going to first of all get a copy of this project into your account forever. Yeah, so you are going to have this project there available in case that you want to review it again next week, next month. You are going to have it there. And also, as you can see, this is going to bring you automatically to the rosject page, which is the one I am here right now. Here at the right side, we have the streaming area, which I'm going to actually move away from here so that I can have some more free space here in my project. So let me actually move here to the class so that I can have the chat here and I can see your comments. Andres is laughing a lot. All right. So yeah. Then after some seconds, maybe it might take up to a minute, something like this, the project page should load, and then you are going to have access here to the contents that we are going to be covering and using during today's class. Okay, then as I always like to say, this is an interactive and a practical oriented class. All right, so I am sharing this rosject with all of you so that you can have basically the same environment and the same material I'm going to be using during this class, which means that you are going to be able to reproduce everything that I'm going to be doing. Okay, and it's not just that you are going to be able to do it, but you should do it. All right, so as I am going to be explaining different things and going through different examples, you can replicate them there from your computers. All right, and have your own experience, see if they work as they work for me, if not, etc. Yeah. So yeah. let's go back here, then let me close all this. So once the rosject loads, as you can see, you are going to be able to see here this Jupyter notebook, which basically contains all the instructions and main content for today. All right, so this is the notebook I'm going to be using for reference in order to do the class. So, so yeah, you can use it as well for reference anytime. All right, so let me know, have you been able to load your rosjects so far? Yes, no? Still loading? Okay, Keshav says yes, Arkham, yes, yes, I have. Also Evelyn. Okay, awesome. Okay, then let's keep going. Let's get started. So, as I was saying, today we are in class number 3 of this series of classes. Yeah, so for the last 3, actually 4 weeks, we have been doing this series about how can ChatGPT help you with robot programming. Okay, so if you have missed previous classes, I really recommend that you go and check them. Okay, you are going to find all of the classes available in our YouTube channel, or if you come here to the live classes page in the construct, here you are going to you are going to be able to find all the past classes as well. Okay, so I really recommend that you go and check them because they are going to provide a lot of background. Okay, all right, in order to do this one as well. So today we are in the last one, which is we are going to be focusing on how to use ChatGPT to understand third-party ROS code faster. So we have already covered how to use ChatGPT to create ROS programs faster, which is one of the main points for sure in which we can take advantage and use ChatGPT to boost our robot and our ROS programming skills. Second one, which was the last class, was how to use ChatGPT to debug ROS errors faster. So, so how to ask ChatGPT for assistance in order to help finding out the reason of a specific ROS error, or even how to solve directly that error. All right. Now, there is another very important point for ROS and robotics developers. So, as you know, ROS, one of the main advantages and strong points of ROS is that it allows to share code that is meant to work in one robot. You can very easily reuse it for other robots, right? So there is a huge community behind ROS, and one of the things that we as ROS developers have to do a lot is to use code that has been developed by a third-party developers or companies or universities or whatever, and then we reuse this code for our project, and then we with a few modifications we can adapt it to our robot. This is something that before ROS appeared, it was nearly impossible to do. It cannot be done. Yeah, so every time that you had to program a robot, you had to basically start from zero almost, okay? And now with ROS, this is not like this anymore. So we have a huge foundation of libraries, programs, etc., that can be used for almost any robot with a few modifications and a few configurations required. All right, so it is very important that we as ROS developers and robotics developers in general, we are able to understand code that has been developed by a third party. Yeah. Then in this matter, ChatGPT can help also a lot. Yeah. So ChatGPT, as you might already know, basically it understands language. Yeah, it's a language model. So this language that ChatGPT is able to understand is not only human language, like questions, words, etc., but it also works for computer language, yeah, for programs. So ChatGPT is also very good at understanding programs and explaining what is the main functionality of this program, right? So this is what we are going to be seeing today through some examples. Yeah, does it make sense so far? Is it clear, this point of understanding third-party code, why it is so important for developers? Yes? Is it clear? No? Yes, says Andres. All right. Okay, so I see that you got the point. All right, then let's get started. So, how are we going to write our prompt for ChatGPT? Actually, this is not for debugging, but for, let me edit this, for understanding code. All right, then here I have basically divided this into two subgroups. The first one is to ask ChatGPT for a general explanation of the code. So you can directly pass a full program, full script to ChatGPT, and then ask, hey, what is this? What is the purpose? What is the functionality of this code? Explain it to me. And then ChatGPT is going to analyze the whole code, and it's going to provide this explanation to you. Yeah, this is the first approach. And the second one is that we can also ask ChatGPT for specific questions about the code. Yeah, so not for a general explanation of what the code does, but maybe, for instance, for just understanding a part of the code, a line that we don't understand, a method, a specific method. We can ask ChatGPT, for instance, other questions as well related to the code, like how would you adapt this program to another robot? What would I need to do? Things like this, okay? And we are going to see all these through examples, because always it's much better to understand things by doing, yeah, than just by listening to me talking. So let's go for that. So we are going to start by checking the first point, which is to ask ChatGPT for a general explanation of a program. Yeah, and for this we are going to use here a code, which is provided in the following post. I have shared here a link. You can click here, and if you want, this is a post that has been generated by a colleague of us at the Construct. And basically here, it's as you can see, it's a post which talks about exploring ROS2 with a wheeled robot. Yeah? And basically it sets up a simulation here of this robot, and then it creates an obstacle avoidance node in C++. Okay, so obviously this is a post, so I could come here and read the post and so on, and try to understand what it's happening here, right? But instead of this, we are going to use ChatGPT to ask him about this. All right. Then here in the project, I have added a slightly modified version of this program, because this one is already quite old. Yeah, and there are some things which are deprecated. So let's come here to the, let's go back to the project, and we are going to open right now the code editor, okay? Which you can find here in the bottom menu with all the icons. You are going to see this one which says code editor. So if you click here, this is going to open a graphical editor that is going to allow you to visualize all the workspaces, folders, files that are inside this project, inside this project. Then in this case, we are going to go inside ROS2 workspace, yeah, SRC folder, and here you are going to find different folders, packages, etc. In this case, I have placed this code, the one in this post, I have placed it here inside the obstacle avoidance package. Okay, and in particular, if you go here to inside the SRC folder, you are going to find this obstacle_avoidance.cpp. Yeah, and we can open this file, and here you are going to see that you have basically this code here. The C++ code that is explained here. All right. Then what we are going to do is to use the prompt that is suggested here in the notebook. So the prompt that we are going to send to ChatGPT is the following. Explain the functionality of the following code, and then we paste the code. Yeah? So let's do this. Let's start here. So let me copy this prompt. Then I'm going to go to ChatGPT. I'm going to start a new chat here. And I'm going to paste the prompt here, right? And then here where it says paste code here, I'm going to just remove this line, and I'm going to copy the code which I am interested in, which is this one, right? So selection, select all, copy, Control-C, and then here I'm going to paste the code. Yeah? And then I'm going to send this prompt to ChatGPT. There we go. Now let's give some time for ChatGPT to explain itself. And there it is starting. So ChatGPT is analyzing the code, and it's explaining in a very organized way, step by step, what the code and what each part of the code does, right? So here we can see it starts, this C++ code is a basic implementation of obstacle avoidance behavior for a robot using ROS2. Let's break down the functionality step by step. And it starts by explaining the includes with all the headers, the class definition of this obstacle avoidance class, which inherits from node, then the constructor of the class, we can see it here. Inside the constructor, we set up a subscription to the laser scan topic, so we can see another method for velocity calculation. Yeah, for instance, and this function takes the minimum distance to obstacles as input and calculates velocity commands to avoid obstacles. If the distance is less than 1, the robot stops moving forward and rotates in place. Otherwise, it moves forward at a constant linear velocity of 0.3 meters per second and does not rotate. Yeah. So as you can see, the ChatGPT is going line by line, and it's dividing the code into smaller pieces, and it's explaining exactly what each part of the code is doing. Yeah, with a lot of detail and very easy to understand, right? I can see. Wait a second. I can see a question there. Guillermo Castillo is asking, does your rosject file open? Mine is taking forever. It stays at 50% and then suddenly drops to 25%. Yes, it opens. It should open. Yes. Give it some seconds. Maybe it's taking a bit longer for you to load, but yes, it should load properly. Okay. Yeah. So as you can see, we can see a very good example here of the first point that we were discussing here. Yeah. At ChatGPT, we can ask ChatGPT for a general explanation of the whole code, right? Now, what about the point number 2? So we can also ask ChatGPT for specific questions related to this code. Okay, so now I already understand the purpose and what this program is doing. So now I can also ask specific questions related to it. For instance, here we have an example. So how can I adapt this code for another robot, right? So let me send this prompt to ChatGPT. Let me copy it here from the notebook, and I'm going to send it to ChatGPT. All right, so now, how can I adapt this code for another robot? Because usually, when you are working with third-party code, what you are going to end up doing is to adapt the code that another developer has created to your own needs, to your own project, your own robot, your own specifications, etc. Right? Error in message stream. Okay, let's regenerate. And there was a strange error there in ChatGPT. Okay, and there we go. So, adapting the given obstacle avoidance code for another robot involves understanding the specific hardware and sensor configuration of the new robot and making appropriate modifications to the code. Here are the steps you can follow to adapt the code for another robot. And then it goes. So first, understanding the hardware. Sensors. Identify the sensors available on your robot for obstacle detection. It might be a combination of laser rangefinders, ultrasonic sensors, depth cameras, etc. And actuators. Determine the type and number of actuators the robot has for movement. This could include wheels, tracks, legs, etc. Yeah? Okay, so for our case, we know that for obstacle avoidance, we have a laser, right, in our robot. Actually, we have not started yet the simulation, so let's go for it. Okay, let's do a quick break and let's start our simulation, because what we are going to do in this first example is to adapt this code to our robot. Yeah. So let's start the simulation. Then for that, we need to execute the following commands that you have here in the notebook. At the beginning of the notebook, in this section, how to launch the simulation. Okay. So down here you have the commands, and then in order to execute these commands, we need a shell, a terminal, right? So to open a terminal, all you have to do is to come here to the web shell icon here in the bottom menu. Yes. And if you click here, this is going to open a new blank empty terminal, all right? So here I can just paste the commands in the notebook. Control-C, Control-V, and then execute this command. And then if everything goes okay, after some seconds, we should see a simulation like this one, a gazebo simulation popping up here in the rosject. Let's see. Okay, here we have gazebo opened. Let me put this here. Right. Okay, almost there. All right, and there we go. Here I have my simulation, my ROS2 gazebo simulation with my robot, okay? It might happen for you, I'm just letting you know that it might happen that when you start the simulation, you have something like this, but in your case, you don't have the robot here. Okay, this happens sometimes due to some gazebo timeouts. All right, if that is the case, if you can see the simulation but you don't see the robot there in the middle, all you have to do is to stop the command that you executed with Control-C and run it again. Okay, you start it again, and then now this second time is going to load. Is going to load properly 100%. Okay, as you are going to see. There we go. All right. Then, following the advice of ChatGPT, if we want to adapt the obstacle avoidance code for our robot, we have to be aware of the sensors that this robot has. In my case, I know that this robot, this Robotics MP400 robot, has a laser, and as actuator, it has two wheels here, which allow for a differential drive movement. Okay? So I know which are the sensors and actuators of my robot. Then step number 2, it says, all right, modify sensor input. Then it says, modify the subscription callback to handle data from the sensor used by your robot. Okay, then it's saying, all right, so be careful, because here in the topic callback, you have to get data from your laser, right? Then I know that my laser data is published into a topic named scan. Yeah? Let me open here a second shell. So if I run now here a ROS2 topic list, I can see all the topics available in the simulation, and I can see this scan topic, yeah, which we can subscribe to it with a ROS2 topic echo scan. Not this, but I need to change my keyboard. There we go. ROS2 topic echo scan, and here I have all my laser information. So actually, if I want to adapt this code to my robot, I need to actually change the information here, the topic, because the sensor input, the sensor data, in my case, it's published not in a topic named laser scan, but in a topic named scan only, right? So this is a change that I have to do in my case for my robot. What else? Well, there are many points here, so let's just go quickly over some of them. So it says adapt obstacle detection logic. So here it says update the obstacle detection logic inside topic callback function. The logic for identifying obstacles and calculating the minimum distance might differ based on sensor type and arrangement of your robot. Okay, this is very important also in my case, right? Because the logic which is inside the topic callback function, which is this one, see? ChatGPT is saying that I might have to review this logic here, yeah? Because here it's assuming some things. So for instance, here it's taking 200 readings from right to left from minus 57 to 57 degrees, okay? This is an assumption based on a specific laser configuration, yeah? Because as you can see, what we are doing here is iterating over the first 200 values of the laser ranges, okay? Then this is valid for a laser which is configured in a following way. In my case, this is different. As ChatGPT says, this is different, all right? So I need to be aware of this, okay? Then in my case, for instance, I know from previous classes, if you attended to previous classes, you might remember this, but in previous classes, with the help of ChatGPT, we were finding out what is the configuration of our laser, right? What is the laser beams that correspond to the front of the robot, and so on. And we found out, with the help of ChatGPT, that in our case, the frontal reading is at 360. So, oh, sorry, I removed more than I want. So, frontal reading is 360. Yeah? So if I want to read 200 positions, I'm going to have to start, for instance, from 360 minus 100 to 360 plus 100, right? This is going to give me the 200 readings in the frontal area of the robot, yeah? So 200 readings from the frontal area of the robot, okay? Which is the one that I am interested in for obstacle avoidance, right? So then, with all this information, I would be able to update the logic here, right? So for instance, E, in my case, is going to start from 260, and it's going to go until 460 to cover 200 readings, like the original code. Yeah? And then here there are more, as you can see, if I keep reading, there are many more things that I would have to consider of the program, but in this case, with this, it's already enough. So let's go back here to our workspace, and I'm going to build this program. Okay, call build, packages, select, obstacle, avoidance. So now with these modifications that I have just introduced, following the guidance provided by ChatGPT, I'm going to rebuild this program. And I'm going to try to execute it for my robot. Yeah? And as you can see also here, so today we are working with C++ code. Okay, so in the previous classes we were working with Python programs. So today I decided to switch to C++ so that you can see that ChatGPT also works with C++ programs. Yeah, it also understands C++ code. Yeah. So let's wait until this is properly compiled. There we go. So now I'm going to source here, and I'm going to try running the code, ROS2 run, obstacle avoidance, and obstacle avoidance node. And then let me go and check the simulation. I can see the program, how the robot is detecting the sphere and it's avoiding it. Okay? It can be improved a little bit more, as you can see, because it still went too close to the sphere, but you can see that already the program is working pretty well, just with a couple of modifications following the tips provided by ChatGPT. Yeah. So now it should detect this wall and it should start turning. Okay. Yeah. So as you can see, very quickly with the help of ChatGPT, I have been able to understand this code, and I have been able to modify it in order to adapt it to my robot. Okay, let me already stop this here. Yeah, and you can make, so here, this is an example of one question, but there are many other questions. So for instance, I can ask, how can I improve the obstacle avoidance logic for the previous code? Yeah, so this is another question that a specific question that I can make to ChatGPT. Yeah, so for instance, we can try it out here. How can I improve the obstacle avoidance logic for the previous code? And here it is, the response from ChatGPT. Okay, or even this. Yeah, let me stop this one. So I can ask, port the previous ROS2 code to Python. Yeah, I can even ask something like this to ChatGPT. And there it goes, the ported version of the obstacle avoidance of this program to ROS2 and Python. Okay, we would have to check it and make sure that everything is correct, okay, because as you already know also from previous classes, ChatGPT is not perfect and might be wrong, but on a first look, it looks pretty promising, okay, the Python code that ChatGPT has created. All right, so here we can see different, we can see with this example, the two approaches, yeah? So we can ask ChatGPT for a general explanation of the code, or we can ask ChatGPT for specific questions related to a code. And with all this, we are going to be able to understand very well and very quickly third-party code. Okay? Yeah? Does it make sense? Have you been able to try out this example? Yes, no? Yes. Jose Manuel Pacheco says yes, but mine hit the ball. Yeah, mine also did hit the ball, actually, but just a little bit. Yeah, so the purpose of this example is not that the obstacle avoidance program works perfectly, but you can see that very quickly we can be able to understand a code and even ask ChatGPT for help in order to do modifications for this code for our specific case, our specific robot in this case. Yeah. Okay, then let's see another example. Yeah, so we are going to work on another example. In this case, I'm going to use this repo, which is laser filters. Okay, this is an official repository from the ROS perception meta package. Okay, you have the link here, you can click it, and this is going to bring you to this repository, which contains a set of different laser filters that can be used for ROS2. Okay, then here you can go here to the include folder, and then you are going to find all the different code for different laser filters. Yeah. So box filter, footprint filter, intensity filter, interpolation filter, and you can go, for instance, inside the box filter and check the code and try to understand what's going on here, etc. Yeah, but if you are not very used to work with laser and with different filters, this might be a little bit tedious. Okay. Especially for some very particular filters like the speckle filter. So many of you are not going to know what this is. Yeah, and in order to understand, you have to look for documentation. You have to go inside the code and check it, etc. Or we can ask ChatGPT about it. All right. So we are going to, in this case, use the same structure. So I'm going to ask ChatGPT to explain the functionality of the following code. Yeah, and for this example, I want to use, you can use another one if you want, okay? For my example, I'm going to use the box filter, yeah? So I'm going to go inside this box filter H file, and here I'm going to select well, you can do it from here or you can do it from the rosject, whatever you want, it's the same, okay? Because if you come here to the rosject, you are going to see that I have also downloaded here this laser filters package. Right, so you also have it here. So yeah, the one I wanted to check is the box filter. So let me come here. You can select also the comments or not, or whatever. I'm going to skip the first part and then copy all the rest of the code. There we go. I think I didn't copy. Let me go back here. Copy. Okay, and then let me go to chat. Actually, I'm going to start a new chat here. And I'm going to ask ChatGPT to explain the functionality of this code. And then I'm going to paste here the code. There we go. Okay, let's scroll down. Let's see what ChatGPT is telling. There we go. So this code defines a C++ class laser scan box filter that represents a filter used in robotics and sensor processing. The purpose of this filter is to remove points from a 2D laser scan that fall inside or outside of a specified 3D Cartesian box. Let's break down the functionality of this code step by step. And then it starts by the header words, header includes, namespace, the class definition, this configure method, which it's pretty important here. This method is responsible for configuring the filter based on ROS parameters. It retrieves parameters such as the frame in which the box is defined, box frame, minimum and maximum coordinates of the box with these parameters, and whether points inside or outside the box should be removed with this invert parameter. Yeah? It has another method, which is the update method, and here it explains the purpose of this. Here it is highlighting all the different member variables, yeah, with the box frame, the mean and maximum. Yeah, and conclusion. In summary, this code defines a ROS filter node that processes incoming laser scans, transforms them into a 3D point cloud, and removes points falling inside or outside a specified 3D Cartesian box, based on the provided parameters. The resulting filtered laser scan is then used for further processing in a robotic system. Yeah, there we go. So here we have a super complete and detailed explanation, which in a few seconds, it allows me to really understand very well what I am dealing with here, right? So this code is supposed to filter laser scans which are inside or outside a specified 3D Cartesian box, right? Which is configured using through these parameters, right? So another question that I can make to the code would be, okay, so for instance, using the previous code, how can I filter all laser scans in a 1x1 meter box in front of the robot? All right, or we could, or you can try another question. For instance, I'm not going to use this one. This is an example that you can use if you want, but I'm going to modify it actually to see that you can do that, and depending on the questions you make, you are going to get different answers. So yeah, so given the previous code, which parameters I'm going to put here? Which parameters should which value should the parameters have in order to filter all laser scans? Okay, so given the previous code, which value should the parameters have in order to filter all laser scans in a 1x1 meter box in front of the robot? Yeah. So, okay, I understand that this code is supposed to filter parameters which are in or outside a given 3D Cartesian box. Yeah. So, what parameters should I provide in order to filter all the laser scans which are inside a 1x1 meter box in front of the robot? Let's see. So now I am doing a specific question. Okay. So I started by asking ChatGPT for a general explanation of the code, and now I am going for more specific questions related to the code, right? Okay, and then here is the answer. To filter all laser scans in a 1x1 meter box in front of the robot, you need to set the parameters appropriately. Based on the code you provided, the parameters that need to be set include box frame, the frame in which the box is defined. This frame should be the coordinate frame in which the robot's laser scans are published. Minimum x, the minimum x coordinate of the robot. And max x, the maximum x coordinate for the robot. For a 1x1 meter box, this should be set to 0.5 meters. Okay? And then the minimum z, this parameter defines, and here it's an example. Yeah? So minimum z is 0, maximum z is 1, minimum y 0.5. Yeah, so here I have all the parameters that I should set in order to have this code filter a 1x1 meter box in front of the robot. Yeah, which means that I stopped the simulation. Let me start it again. All right. So I want to filter all laser scans which are in a 1x1 meter box here in front of the robot, right? So yeah, here I have a super complete answer from ChatGPT, which I can even use this to to configure the laser on runtime. Yeah, it says assuming the laser scans are published in the base laser link frame, the parameters should be set as follows. Yeah, so what I'm going to do here is to try this. Yeah, I'm going to try what ChatGPT is telling me to do. So let me start the filter here. ROS2 run. This is laser filters. And the filter that I want to launch in my example is actually box filter example.launch.py. Yeah. So box. Yeah, it's ROS2 launch actually, not run. Laser filters box filter example.launch.py. Okay, there we go. And I'm going to start one more thing here, because here I am running the filter, but in order to actually visualize if this is having any effect, I'm going to start RVs, right? An RVs instant in order to visualize the laser information. There we go. And then here I'm going to set a predefined configuration file that I already have created for this class. And you can find it here in config, user, ROS2 workspace, src, laser filters, and here it is, filters.rvs. Okay? You can open this rvs configuration file, which is already configured to show this. So right now, here you have the original filter in red, and the second one is the filtered. Yeah? So here you can see the scan topic in the first one. This red one, let me uncheck this one right now. See, so the red one is the original laser scan. And now if I activate the blue one, this one here, this is the scan filtered. So this is the result provided by the filter. Okay? So right now I can see that in both cases, the laser is detecting here the sphere in front of the robot, yeah? If you have both activated, you are going to see that the two of them are detecting it, right? So what I'm going to do right now is to, first of all, I'm going to move the sphere a little bit closer to the robot, yeah? So let me move it closer to the robot so that it is in a 1/1 meter range here. There we go. Okay, so now I have it much closer to the robot. Okay, and now what I'm going to do is to try to apply what ChatGPT told me to do. Yeah. Then first of all, I have to set the parameter box frame to the frame in which the laser is publishing, which in my case is base link. Okay. So ROS2 param set. Actually, let me check the node, which is, I think it's laser filters. Yeah, it's this one. It's scan to scan filter. Yeah. Here it is. So here are all the parameters that I can set with the ROS2 param set. Okay. So this is one option, but I think I'm going to go faster if I actually change them directly in the YAML file, which I can also do here. Yeah. So here I have a YAML file where I can configure all these parameters as well directly. Yeah. As you can see here. So we have both options. Let's try. Okay, let's try this so that you can see it as well. So ROS2 param set. This is scan. And this is box frame. This is, actually, let me get this value because I think it's already set correctly. It's already set to baselink, right? Baselink, yeah. So we can set here the other values, which are filter 1 params max x to max x to 0.5, min x to minus 0.5, and min y minus 0.5, max y 0.5, or min z 0 and max z 1. Okay, actually, I'm going to make it a bit bigger to make sure that I am filtering it. Okay, so let me actually set the max x to 1. Okay, so the parameter is read only. Okay, no worries. Then what I'm going to do is to change it directly in the YAML file, okay, which is going to be even faster. So yeah, let's come here and let's change it here. So the max x, I'm going to set it to, let's say, 1. The min x to minus 1. Okay, then the y, it says to go also from minus 0.5 to 0.5. So let's do also 1 and minus 1. And then min z, actually this should be 0, because it doesn't make much sense to have anything above the ground. And max z can be 1, for instance, right? So let's do something like this. Then let's recompile our package. Laser filters. There we go. And then I'm going to launch again my filter. And what we have right now is that already the blue laser is not appearing here. Yeah? And because if I zoom out, I can see that the laser is there, right? But the blue laser, so the filtered one, already is not detecting this ball. It's being filtered out. See? In the filtered, the ball doesn't appear, and in the original, the ball does appear. So yeah, so actually, ChatGPT has explained it very quickly, the purpose of the code that I have shown to him, and it even tells me very easily which are the parameters I should change, I should tune in order to modify this box filter, right? So very quickly I have been able to understand and modify the code in order to fit my needs. All right? Yeah? And again, I have started, in my case, I have applied both approaches. So I have started by asking for a general explanation of the code, and then I have switched it and I have asked a more specific question related to that code. Yeah? And we have here a final example. This one I'm going to leave it for you, that you can try it out. Okay? It's quite interesting as well. So, well, actually, let me show it to you very quickly. So, in this case, I'm going to try with a even more complex code, right? So this is the movie 2 tutorials repository, official repository from ROS2 as well, from ROS planning. And then here there are many codes, many programs that can be checked, but these ones are pretty complex. So let me look for one program. Sorry. Examples. For instance, move group interface. Let me go to this one. SRC move group interface tutorial. Okay, for instance, this one. This is a good one that you can try out. I'm going to share it here in the chat in case that you want to try it out. There we go. Okay, so if you have a look at this code, you are going to see that it's pretty large, many lines of code, many things. Okay, keeps going, almost 500 lines of code. Okay, so I'm going to change a little bit the question in this case. So instead of asking ChatGPT, explain the functionality of the following code, I'm going to say, hey, break down into smaller pieces and explain the following code. And then I'm going to paste the code. Okay, so let me actually copy this to ChatGPT. Let me create a new chat here. And then now I'm going to paste the whole code here. So copy and paste. There we go. And then ChatGPT is going to start analyzing the code, and it's going to break it down into smaller pieces as I have requested, and explaining all the different parts of the code. Yeah. So it starts license agreement, header files, node initialization, planning group initialization, path constraints and Cartesian paths, collision object handling. There we go. Okay. So we can use it for many different things, and even for quite complex code. All right. So let me go back here. So let me know, because I see that nobody is writing anything here in the chat. I don't know if you are following the class, if you are not following me at all. So let me know. Does it make sense? Have you been able to follow the class along me, understand the different parts that I was explaining? Have you been able to test yourself? Yes, no. Alberto, amazing, says Andres. Thank you, Andres. So I hope that you got the point that I was trying to transmit. Also, Jose Manuel says yes. All right, great. Then yeah, so I'm going to basically close it here, leave it here. So summarizing what I wanted to show with this class is that ChatGPT can help you understand third-party ROS code much faster than you would do otherwise. Okay, and as a ROS developer, you are going to find yourself analyzing code that you have not created lots of times. Yeah, and you are going to have to analyze it and really understand what that code is doing, because you are going to have to do some slight modifications, etc. So this is a very common scenario in robotics. All right. So for these cases, I am telling you, and I wanted to show with different examples, that ChatGPT can be very helpful in this process of understanding third-party code. Okay, and it can help you boost your speed. Also in understanding this code, so that you can then add your own modifications to the code to adapt it to your robot, to your project, etc. All right, so yeah, then thanks a lot for all of you that have been here on this class. I hope that you enjoyed it and that you have learned something that you can use in your career, in your development, in your own personal development. So yeah, thanks a lot. I'm going to see you again in next week. We are going to finish, so today we have finished this ChatGPT series, then next week we are going to work on other stuff. But yeah, I hope that you enjoyed this series. Probably we are going to come back to things similar to this or related to this in the future. But yeah, so let's leave it here. Thanks a lot for being here with me in this class. And as always, take care and keep pushing your ROS learning. Bye bye.